Hello guys, this video is in continuation of your earlier class. In the last class we were discussing about induction disk type relays and we came to know that there are two types of constructions of induction disk relays. The first one was shaded type and the second one was watt or meter type. In that we discussed shaded pole type in complete. So now in this class we will be discussing watt or meter type induction disk relay. Okay. So this is the picture of watt meter type induction disk relay. It consists of two electromagnets. One is used in upper side and the other one is used in the lower side. So each magnet produces its own alternating flux cutting the disk. Your upper as well as lower magnet will produce the flux so that both fluxes will cut the disk. In order to have phase difference between those two fluxes, both the coils should be energized by two different sources. Then only we will get the phase difference. And I already told you how phase difference matters a lot here, because due to the phase difference only the driving torque is produced so that your disk will start to rotate. So to achieve this, you need to energize these two coils with two separate energy sources. If you don't have two different sources, then a circuit has to be rigged up so that resistances and reactances of both the circuits shall be made with different materials so that sufficient phase difference is achieved. Okay, so the resistance and reactance should be different so that a phase difference can be achieved if you have only one energy source. And this is the plug setting multiplier which you all know. This is the secondary coil and this is the primary coil you can consider, and this is the relay coil, and these are the two magnets, and this is the brake magnet which is of permanent in nature. In the last class we were having this brake magnet as electromagnet, but here they are using permanent magnet so as to produce the eddy current, in the aluminum disc. See, this magnet should remain stable and all, because if it remains stable, the accuracy of the system of this relay will not be affected. So the braking torque which is produced by this C-shaped permanent magnet is proportional to the speed of the disc. More the speed of the disc, more will be the braking torque. So when the operating current exceeds the pickup value or preset value, so what happens? The driving torque is produced in the disc so that disc starts to rotate. And again the braking torque which is produced by this magnet will be balancing the driving torque. Okay, so the disc rotates at a speed proportional to the driving torque. So the constant speed depends upon the current applied to this particular relay. And again here you should remember that the inertia of the disc should be very small. If the inertia is more, then what happens? The disc will fairly start to rotate. And again after removal of the fault, the disc should stop within fraction of second or without making any delays. Okay. So if applied current is less than the pickup value, then disc will not rotate. That is, the driving torque will be lesser than the restraining torque or opposing torque. So the disc remains stationary by the tension of the control spring against the normal action of the disc rotation. Means the operating torque should be greater than only the disc rotates, otherwise the disc will be constant or stagnant, because since spring is utilized which opposes the driving. So only if it exceeds, then only the disc shall rotate. Now when this disc starts to rotate, let us say this R is initially here Okay, so that when it starts to rotate, so that what happens, the operating torque will be obviously greater than the restraining torque, so that when it reaches here, it shorts the trip circuit, it connects the trip circuit, so that whatever as per the design, the circuit breaker will open or close. Okay, and again remember, this disc is pivoted on the spindle with the jewel bearings, so that for smooth rotation without any resistance except your spring. Okay, so this arm will bridge the trip circuit whenever this arm reaches from this point to this point during the rotation. Okay, like this. Like I told you already, this is the plug setting multiplier, which consists of current setting as well as the time setting. As per our desired need, we can set any pickup value of the current so that relay should operate. Like I can set for 1 ampere, 2 ampere or 3 ampere. The relay will operate only when that particular ampere is crossed. Along with that, we may also have the time setting multiplier in this. So time setting multiplier in sense what? I can set desired time for my wattmeter type induction disc relay to operate. Like I can set for 5 seconds, 10 seconds or even 15, 20, like this. I can set the time in seconds, so that the operation, the desired operation duration of time, I can set the for this particular type of relay. You can set current as well as you can set time. And this type of relay has inverse time current characteristics. Till now we discussed induction disc type relays. Now we shall see induction cup type relays. So this is the figure of induction cup relay. You can see we have 4 poles over here, that is a stator part, and there is a rotor part. The rotor part, you can see there is a stationary iron core placed inside the cup, and this cup acts like a spindle. Again, to the spindle we have connected one arm. Okay, here one thing you need to observe is there are 2 actuating quantities are applied. One may produce the operating torque and other may produce the restraining torque. So here, like other cases like induction disc type relays and all, we were having brake magnets, but here we don't have any brake magnets. And this induction cup relay operates on the same principle as that of induction motor. In our figure, it has 4 poles, or it may be even 8 poles as well. Here in our figure, rotor is hollow cylinder. It has 2 pairs of coils, you can see in the figure. Yes, so these 2 pairs of coil produce the rotating magnetic field, so that induces a current in the rotor. So due to the interaction of the magnetic field as well as the current, causes the rotating flux and thus causes the torque is produced. So thus your rotor rotates. So here one thing you need to observe here is, in such type of relays, can call also advantage, the inertia of the such cups are what? Very less when compared to that of disc. Again, such type of system is even more efficient and also has very less magnetic leakage in the magnetic circuit. So due to this, the resistance of the induced current in the rotor will also decrease. And here this type of relay has got very less weight and effective magnetic system, and also more torque when compared to that of induction disc type. So here VA burden is also very less. VA burden in sense what? The load connected in the secondary side. So if VA burden is less, then such type of relay possesses even highest sensitivity as well as high speed. And here the torque is non-vibrating, so uniform speed can be seen in the rotor. So its operating time is of around 0.01 second, so less. So it is suitable for high speed operations. Wherever we need a high speed of operation and all, you can use such type of relays. Wherever the time parameter matters a lot, there you can use. Here one thing, that is, it is again I can call advantage, it is having less sensitive to the DC transients. So that is the added advantage. And also it has got the pickup and reset values very close. So due to this, what happens, it can easily distinguish between normal as well as the abnormal condition. So such types of relay are widely used in the distance and directional relays. That will be again discussed in the coming classes. What is distance relay and what is directional relay and all. So nowadays even these relays are also replaced by bridge rectifier type static relays. So now operation concerned, which you already know that even this type of relay also has spring in it, so as to provide the resetting torque, just like it was in our case of induction disk type relay. So whenever the operating torque increases the resetting torque, the rotor, the cup rotates, and again this spindle will make contact with this spindle, that is a fixed contact, so that it is again connected to the trip circuit, so that the circuit is tripped depending upon the design. Operation is almost same, just we have again a trip circuit, only the movement is required, and this is a induction cup type of relay. This is how it operates.